Hello everyone, this is the fourth episode of my modeling session where I model my robotic hand version 3, and this is actually the Thanksgiving special. So I have my Thanksgiving water, and I have my Thanksgiving armband, which I'll put on right now. And then this is my Thanksgiving stream, so yeah. I'm gonna pick up where I left off last time with me creating the hand, right? Yeah. So I remember last time when I did this, I happened to completely mess up the process with me creating the linkage system for the hand. So I'm gonna remove that. So I actually think that's fine if I keep this, but I should be removing the ones where it was like the ones that were messed up. So I'm gonna get rid of that. I'm gonna get rid of this one. Yeah, I'm gonna get rid of that. So it's just the I actually don't know why I have this. I kind of forgot what this was for. So this was for that to go out through there. Which, okay, I'm gonna get rid of that. Actually, yes, I'm gonna get rid of it because I kind of don't have a use for it, really. Well, I probably do, but I forgot what the use was, so I'm gonna delete it. Okay, so now we have the finger. Now we just gotta think about how this is attached. Where it's like, this is a whole single piece, right? It is. So this is attached in a way where it's like, I gotta watch the video again. Kind of forgot what it was. The Robot Studio finger linkage. I think it was part 4.
Right ligament.
Is it? It's not. This one is the knuckles. It's part 3. Yes. So with part 3, he has a where
Takes
it's like
it's going to step. That is how that
see?
end is attached
Yes.
of the figure 8 ligament down through that hole there. Yes, I'm using them.
Yes.
So now we have started the figure 8.
I see. So one's going to the bottom, and the other one comes out through the top. So I'm gonna undo what I did where I deleted that, right? So one would go, I see, so this would go through here, and the other one just is flat on the bottom. So to do that, I will actually I actually would like it to be symmetrical for the tendon system, right? But it doesn't have to be symmetrical. I could see it being where one tendon is here and the joint is here, but I don't really like that concept. So I'm gonna make it where the two. So this will actually have three tendons on the inside actually. So driving tendon and the connection tendons. So I'll have it where the two connection tendons meet at the end and connect there. So you want one to. I see. It's at the end of the finger. So it's actually like this. And then one goes in, comes out to there, and the other one just comes out to the back. So that's actually fine. I'm just gonna put this back. So it would really just be kind of where one would go out to there, another one goes through there, and then this gets held in place. So I'll put like a screw through there. That's actually good.
So now we have started again through there,
And then
up diagonally.
it's a figure 8. So for this one, what I'll do is I'll actually cut out a cross section, so I'm able to. Do I have to? Yes, I do. So I'm gonna put a cross section here. I'll put a construct there, and then I can also just mirror it instead of having to do it on both sides. Right? This mirror is a function, right? Is mirror a function? Is it not a function? Yes, it is a function. And now I mirror it here. Yeah, okay, we're cool. Yes, I'll actually do a mirror line right here. I'm gonna do a mirror line where it's like construct line, but it's in the middle, right? So I can just mirror it. Okay. Now what I'm gonna do is I'm gonna split this right here. So split body, split it right here, bam. And then I'm gonna get it out, bam. And then what I'll do is I'm gonna, look at, I have no idea what happened there. Why is it so small? I don't know. Doesn't matter. Alright, so if we think about it, one is going through here, and then
Part of the ligament.
it's really
This is
just going through
small
the joint.
end
The,
towards
the joint doesn't really matter. So it's actually more so that the okay. So I just realized that the Robot Studio has his joint where the bearing and the bearing I guess the bearing rod is actually connected to this. So this is a whole part, but I have it where the bearing rod is actually connected to the phalange that it's not connected to. So this part should actually be the one with the
tip.
bearing, but I don't think that is really of much concern. It really shouldn't be, or should it? No, it's fine. So what is this? Okay, this is the sketch that I'm making. So one goes through there, and then it just goes here. So I think it's fine if we just do a circle design. A circle loop. 6. Nope, go back. Bam. This is fine. And this one I'll have it at a 4 millimeters. There's a 2 millimeter gap. So one will go through here, another one will go through there. Right.
Sure, you have. And it's going to stay.
That's good. And it's gonna be wide enough so they don't intersect with each other. For this, I'll find this part. I'll find a 45 degree right there. And from the 45, I'll go an angle of 45 as well, up to there. And this will have to be a millimeter. This should be 2 millimeters. This is 6 in it. This is 6 and this is 4. So there should be 2 millimeters in between this. If this is 6 and it's 4, then how is this not 2? Oh, it is 2. Okay. It is 2. Because it is actually, it's good, I'll just put it like that. Bam. And then the other one, this should be also at 45 degree angle. Not 435, 45. And from 45, this will be like this. And then look at this at 45 as well. And then I'll just have it go out all the way. So now what I'll do is I'm gonna move that back. I'm gonna hide this, and then I'm gonna I'm not exactly sure how I'm gonna do this, but okay, maybe from here. There you go. Right. I wanna get that, and I wanna get this, and I just wanna get that one and this one, and then what I'll do is I'll just hold on, wait a minute, these are also should be going out like that. Oh my god, just almost messed up my whole thing. Alright, so this should actually be also 1, and just going out like that, because it would go through there and it would go out through there. As to that's good. As to this one, I have no idea why I made it a circle, actually. Instead of a circle, I could have just had it be just had it be like that, but that's okay. And then for this, why don't I just find the middle of these two, right? So that's the middle, and I just put it as, I don't know, 2, or no.
And you can just check to make sure that they haven't twisted over each other. And you can just check to make sure.
So I think instead of doing this, all this complicated stuff, what I'll do is I'll just do this. I'm gonna get rid of that. I'm gonna go forward a little bit. So I'll actually get rid of this constraint, or this offset that I made. I don't really need that. What I'll do is I'll just look at the top of this, go through here, and then I'll just create, I have no idea, maybe like a 2 millimeter triangle. Okay. So from this, I'll just get from 1 to, this is gonna be 2, right? Yeah, that's pretty good. Yeah. And it looks like this is here. I'll do a 2 millimeter as well. So I'll just push these down, and then I'll use a fillet to fillet just to smooth it out. So I honestly think this will do the trick instead of doing the weird X with the circle thing. That's fine. 2. It looks weird. 3. Looks good. Alright, yeah. So that top joint goes through here, and the bottom joint. Yeah, so the bottom joint actually comes out through there, right? And then
But we have there, other way towards that side.
and then it would actually, you would want it to have like a nice, I guess, tubing to go through. This actually seems to be a bit too high, so what I'm gonna do is I'm gonna cut this down to length up until here, which it's a really weird one. I don't like that. Let's do -2. That's good. -2 is good. You want this to be as close to that one as possible, so I'll cut this down as well until here. And this chamfer is kind of messing me up right now, but that's okay. The chamfer doesn't matter. That's fine. So what I'll do is okay. So what I'll do is instead of the chamfer here, I'm gonna get rid of this one too. This one looks kind of weird. Alright, I'm gonna do that, and then I'll try doing the fillet again. Fillet this point, this point, this point, fillet that point, this point, this point, and that point. There you go. And I'm gonna do a 3. That deleted my whole thing. What about a 2? It's almost round. What about 2.5? 2.5. Oh, that's pretty good. That's pretty good. Well, I think I'll stick to 2. Alright. So this one goes through here. We should honestly really be kind of going through it on the inside. I don't want it to be going out through the outside. So what I'll do is I'll create like a channel for this to go through. So when the string comes out here, and then I'll do this. So when the string comes out, this will be a 6 by 14, and this will go up, I don't know, like 2.5. That looks a little funky, but it's alright. And then from here, if we look at the channel, we could really just do one big one, just because of the fact that it's 11? No, it's 12. We could just do one big one. Just okay. I don't want to do one big one. I just want to let's do a 4. Yes. So I'll actually make it not one big one, and it's just like that. So and then these go through here, and then they loop, and this one goes to the top, goes straight in. This one loops through here, goes out, and what does it do here? I don't know.
Low inertia
Low inertia motor. Low inertia motor.
It's going to stay towards part
Yep.
of the ligament.
So what? So he has it where it's actually coming out, and then it's not really going through. It's more of a like a. It's more uniform than what I have, where mine just goes out and just looks weird, right? That looks weird. It looks funny. So I'm gonna make it more uniform as to it has more of a path to travel through, instead of just being like free, just, you know. So it's kind of blocky, but I think blocky is good, since it's just the easiest to grasp at what I'm looking at. So then this one goes out through there, and then this one goes through here, and then this one seems like it would also go through a channel there.
Just chip pen onto a knuckle section. A longer screw it on.
So for the knuckle section, he does a lot of these heating inserts,
Simply
which
goes
seem like a pain to
straight.
put on, but I feel like that'd be way better than
Now,
a screw.
the-
So the lower cable
I'm gonna pass through this hole.
passes through there. Ah, I see. So he has a hole in the actual proximal phalange. So it seems like this one will just. Oh wait, what? So this one goes through there, and then passes through a hole in the proximal. As to, wow, I am getting like dazzled by which side is up and which side is down. I thought this was down for a second. So this one would, this one will go as to, that one will go through the top, go through there. So this is actually the top of the finger. So that's crazy. And he
Through
has
this
it
hole.
where, yes, so that will go through there and come to the back. Okay, so I also need to make another more of these channels right there. So I'll just I can't extend that, so I'll make it here. I'm gonna go here, find the midpoint of this, which I don't know if I can. Okay, maybe not. So I'll actually just do it on the actual plane. If I measure just out from here, this should be 4. Yeah. What kind of number is that? I never seen that. So out 4. Seems like it'd be 4.5. Nope, 4.2. Wow, 4.2 is the answer. Yes. So this one also be 4.2. It's not, because although it is on both sides, it seems like from where I look at it here, this isn't actually the midpoint. Because look at this. Look how this and this are not the same. Small error. Yes, look at this. Although this is the same, this one is more farther out than this one, which could lead to some trouble. So I have to fix that. As to where it is, I'm not exactly sure. Probably somewhere around here. Yes, probably this one. So what's the sketch here? It's not even. Is it not? So we go from here to here. The actual midpoint to the top. From here is 4. Here is 4 point. I see. So that's what was wrong. So go from midpoint of this to here. Here to here is 4. Here to here is 1.64. So what is 4 minus 1.64? 4, yes. So 0.164. Let's do this. 4 minus 0.164. Oh crap. so it's 3.836. So this, instead of 4, this would be 3.836. There you go. So now my sketch is fixed. Now it's the same. So if I go to the one I just made, now there should be the maybe almost the midpoint. So it's actually just 4. Yep. And then I'm guessing it was a diameter of 2. Or I think it was 1.5. That was 2. It is 2, okay. So with the diameter of 2, we're going to extrude it out until it's out. Right? It looks like it's chipping into the bearing. So I'm going to remove the bearings. Then I'm going to extrude it. Extrude it out. Perfect. I want to get these, which I don't exactly remember where these are coming from. I'm gonna move this for a second. Seems like this is off. It is off. The other one is off too. Not good. So this one should actually be level with this. Is it that that should be level with this, or the other one should be level with that? If it's even, then if it's whole, it's, this is 10. Okay, so this one is that's the one that's off. This one should be level with this. And what is the thickness of this? 0.048. That's okay. That's a number so small that in what I'm making, it doesn't exactly mean that much. I don't even think the printer could print that much, bro. 0.048. That's less than. I mean, that of course that's less than a millimeter. That's less than like 1/10 of a millimeter. It's tiny. Okay, and what is the thing that I want to make here? Looks like I would have to. I'm not exactly sure how I made this last time. I'm guessing I just, just made a circle and I extruded it. What is the diameter of that circle? Probably 10. And then it looks like I just made it half, right? I put one right here. I put one at the top. And then I guess I extruded it. Maybe something's off here. Yes. Is that touching the circle? Yes, it is. So this one, how come this one isn't the actual part of the circle? This one would have to be, what is this? 6. Yeah. I'm gonna delete that. I'm gonna go from this to that. And then this would go inwards too. Yes. I feel that the diameter of this might actually be too large. So I will cut it down to just 5. No, not the inside. The outer diameter. of which is 10. I want it to be just 9. A millimeter of gap should be enough. Yes. And with the extrusion that I did, I'll get rid of this top part. This bottom is okay. Maybe not. Oh, duh. Huh. Okay, so with the extrusion, this top shouldn't really be part of it. I'm not sure what. Let's look at this. Yes, look. See how this is small, but the other one is large. It's not. When was that a part of that? When did these get fused together? I don't remember these being fused together. Crap. Maybe I think it's when I extruded these out. No, it's not, because it's after that. Okay, that's fine. Yep. That's good. I'm gonna do construction here, and then up until maybe right there. Nah, I think I'll just find the root of this, really. That's okay for now. I just want to see when this was. Oh no. This was like when I fixed everything, right? Oh man, I don't know what's going on. So looks like, you know what I'll do? I'm gonna fix this first. This has really been bothering me. The fact that this is 9? No, it's not. the outer ring. And then this one should be 10. And the fact that this is cutting with that really bothers me. And that's good. But let's think about how we're gonna split this. So we're gonna do construction here, construct from here, construct upwards until it's a little above that. But let's just see if it works. We're gonna split this. Oh no, these are already separate bodies. I can just combine these two to create one body. And then I'm gonna move these back. Looks like this is good. And the other one, where I will have to move those back. Not for now though. I'm gonna move these two away, just for now. Oh my god. No, it's cool. I thought this was. I know it's intersecting, but I thought it became like a part of it for a second. I was like, whoosh. Okay. I actually don't quite like how this is a how this is it's not level, right? And then since this is level, each one is be level to there. All right, and the other side should be the same. Bam. I'm gonna move this, move back, and then move the whole thing. There you go. Alright, so now let's get with this one. where you start from here, and then you'll do a 9. So do a 9 from here to here, from here to here, and then the inside was, what was it, 6? Yeah. So -2. Boom. The other side, we'll go with a 9, with a 6, like 6, 9. I did the, I sketched it on the wrong plane. Should be on this one. With them, let's go with a 9, and then a 6, and then from here. So this is 6, okay. So this should really just be up here, and this one should be intersecting up until there. So now when we do this, we're gonna do -2, and that should join it. Alright, let's get rid of this move we did. Let's get rid of this one. Let's get rid of this one. Awesome, looks good. So now the ball bearings are in place, while this one, which we'll put through, is able to go. Bam. Alright, so looks like this is good. With this one, we should be having the, oh crap, I forgot to put the take the ball bearings out before I did that. Before I extruded it through. I drilled it through. Bam. Alright. Now move back. Boom. Looks good. So now goes through here, inwards. This one, it just goes in like that. Well, the other one, no. This one goes through here, and then goes here. This one goes down here, goes through here, goes in here, goes to there, and then it should be it should be coming out through here. So I think we'll do just like a thing here. Let's see. So it looks like this is the actual spot. Since it really just connects it to one, I think it's fine if I have it as one, but I'll keep it as 2 just for the sake of having it as 2. Maybe it'll provide more stabilization or something. You never know. You never know till you try it out, I guess. Move this one up, move the other one up. Alright, now we're gonna extrude it down to here. Comes out there. Crap. You know what? That's fine. Gotta get rid of this weird thing I did on that. I don't know what this was. I don't really know what that was. This one, is it? It is this one. Yeah, like that. Okay. So these ones just go out through there, and then it'll actually oh, what? What happened here? Okay, and then this will just be a fillet. It'll fill it out. I don't know, fill it out 3. And then it goes in. And then the top ones just fill it into there. I'll put a thing this way so that it's like, I don't know, it's 3 millimeters. Oh, that's tiny, but it's okay. Whoa. Okay, I'll do a, I don't it was actually okay once when I had that one. I'm gonna make this a little larger, maybe halfway. So with it halfway, I can scale it too. Oh my god, that's huge, right? Okay, and I'll just do a chamfer. Cause I don't know, just chamfer one looks good. So now with the linkage, it's gonna go through here. This one comes out. This one goes into there. This one goes through here, goes here, goes into this one, goes here, bam. Right? This one goes here, straight up. So now I think the joints are good. The ball bearing should be arriving pretty soon. So this is like a new method. I press C and it creates a sketch. I didn't know that. Okay, I'm just gonna hide that. Alright, now it's time to make this colored. So I want to make sure I know that they're different parts. So since they're all like gray, it's kind of hard to tell. This will be this one, and this will be the neon. But I don't really like the neon. I like it when it's like moss. Oh yeah, it looks tactical, but I don't know what's up with this. Is this supposed to be part of that? It is. Okay, there you go. Now that the neon, I mean this green looks weird. Maybe it should be more like that. Maybe like this color. Can you tell that they're different colors? Not really. Kind of similar. Oh yeah, like a sky blue. Like a grayish blue. That's good. I'll be honest, that looks horrible. I don't like that at all. I'll do a gray looks weird. It looks weird. That's not bad. This is like the same color as the other one. Maybe like a purple. Oh yeah, that looks awesome. Purple. I don't like how this is also blue. Maybe this one should be the blue one. And then I'll have another one where it's like, it's also not purple, but it's like more pink. Yeah. Oh, I forgot this was a two-parter. Yeah, okay. So this is more like this. It's like a little darker, but still like the same color. And then, hey, it looks awesome. I can tell that it's different, kind of. I don't know. The contrast isn't exactly it. I think that looks pretty good. Maybe this should be. Honestly, no, this is good. So now we should just think about. Now we really don't need to even think about the tendon anymore. It's already good. Really. Maybe all we need to do now is put a support tube right here. Support tube as a way to just make sure it's like supported or something. Let's see if my guessing game is gonna be correct. It's gonna be 4.2. So, bam. And then the 2 should just slide into there. Now I'm thinking, should I make this a two-parter so it's easier to put the tube in, or not? Should just be one. Maybe. Just maybe. Okay, well, seems like the finger is basically done. Which is quick, very quick. I can probably do a slight modification to the servo horn, in which it's wow. That really was quick. Okay, so this is the part when I print these things out, and then when I print it out, it's way smaller than I thought. It's like kind of fragile. So actually, I think what I would want to do is I would want to make a prototype first, make sure it works. But I'm just now thinking, how can I make the fingers different lengths, right? Nah, that's very easy. Just cut this down, and then I actually don't know if there's much of a difference in the length of your. Actually, no, there is. I was thinking about the middle phalange. For maybe some for the other ones, we can cut this down a little bit too, and the distals. I'm not sure about the distals. I think all of your distals are maybe the same size. Kinda. Pinky's seem just the smallest one, huh? Well, yeah, obviously, but like, I didn't know your pinky had smaller distal phalanges. Okay, I'm gonna save this. I'm gonna print it out, but you know, until I print it out, I think I'm just gonna watch videos of Dexhand.
That's not good, is it? Okay, that is much more like it. Still some minor striations, but very neat now. Good surface finish. Excellent. Okay, so that is fresh off the printer, and now that is dialed in. That really is very good. Turn it sideways. You can see some very slight band on. Cut a bit tight. Cap, I can live with that. Shaved off the top edges, so just the rat printer and the parties, you know, sliver bearings, grams. But there, that's flawless. That could be just a few percent of my. The will end up being a touch abrasive.
This is a Hope Junior hand, right? Yes, it is. I remember for my first draft, I had purchased these very small springs from I think some hardware store, and what I wanted to do was I had wanted to put them at the end of each phalangeal joint, at the end of each joint really, and then I wanted to see if that would actually make it have enough retractional force to make it like a functioning hand. But what I hadn't realized was the servos were far too weak and the springs are far too strong. But I can also see that for here, these must be kind of weaker springs. And he also has it where the hand has just two joints, with the last two joints of the proximal, not the proximal, the proximal is proximal, and just the last two joints are fused into kind of a little bend shape. I see that trend with robotic hands a lot, but yeah. His thumb designs are always quite amazing.
They are slightly different in length. You can tell which is which by the distance between those holes, because that part is interchangeable. So you can remove the end, which is a nice neat pattern, and that's very strong if you twist it. Okay, so here I'm just going to take it through the opposable routine.
I think extension springs are one of the most perfect materials as a way to make flexible tubing. Just because of the fact that it's not really what it's intended for, but it does have great qualities in the fact that it's not like something like Teflon. Like here, it's not rigid, right? It's very flexible, and you can like bend it, but it still acts as a tube. So, and it feels nice. It feels very nice to the touch. It's cool, metallic.
Make sure all fingertips.
What is Hugging Face? I always see Hugging Face, but I'm not sure what it is. Is some sort of company? I see like the face with it's like smiling, it's doing this, but like I'm not exactly sure what it is. So, I've really finished the basic design prototype already. I don't really see any further use in designing more until I have it printed out, because everything looks perfect on paper, or in this case, everything looks perfect on screen. But in real life, it's very different, and there's lots of factors that influence what could go wrong, and especially in something like this where I kind of just freak at this off my head, which I think that's how most people look at it. But I hadn't really, well, I have put a consideration, but I haven't put exactly just lots of concentration into how it might function, which I have done that, but I fear that it might not be adequate for the way that it will actually function in real life. But one thing I will actually do is you know what, I don't even wanna do this. I don't even wanna connect this. You know why? Because when I print it out, since it's gonna be plastic, I'll just solder it. I'll literally just take a soldering iron and I'll just solder the joints together. That's what I'll do. So, yeah. But this is all of this is one piece. So how many pieces? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10 pieces. I think I might have counted that wrong, but that's okay. It's not very important. But now what we'll do is my favorite part here, making the what the heck is making the simulated design that I like. Let's do a 3-degree rotation, huh? I think 3 is good. And then this can be the middle finger actually. We'll do a 6. What the heck? No. I'll go back. We'll do a rotation of 6. Oh, no. Go back. No. Okay. Do I... So, it looks like I don't have a copy. I haven't made a copy. Alright, I'm gonna copy this, paste it. We're gonna do a rotation of 3, and then this will be the ring finger. So then we'll do a rotation of, I don't know, 6, and this will be, for now, this will be the pinky finger. I know that for a pinky finger it's very long, and pinky fingers aren't very long, but you know, it's just a fun little thing I'm doing just to kind of gauge what it might look like. But hey, this is actually way more from the wait, so this part is actually kind of like an actual hand. I think will be around this size. But yeah, it does look very good. It's way much better of an improvement because instead of V2 where it's like this whole thing, the hand, this is it. This is the only part of the hand that moves, and maybe this will go up like a little bit like that, right? But that's fine. What I'll do is I'll reverse this mode and I'll put it on there, and I'll have it in like a square shape. But yeah, wow, looks good. It's way smaller. It's way slimmer, and I actually have enough. If I just move these up a little bit, I have like this much space to work with the thumb mechanism, which the thumb mechanism is really the most important mechanism. If you don't have a good thumb mechanism, you can't really do anything. I mean, try doing just simple tasks without your thumb. It's very hard. I mean, can you do a lighter without a thumb? I don't think so. You know, can you? Okay, maybe you can do like this, like hold like this, and then you go, like that. But you know, without a thumb, you can't really do much. Yeah, maybe in the future, I'll make like version 4 or something, where it's like you can have like a non-invasive BCI, and you can just control it with your brain. Because for now, you know, people will be like, wow, this is for amputees, and you're like, well, how are amputees gonna control it? I don't know. BCIs, I mean, Neuralink. I think Neuralink already has a patient who I think he's like missing his arm or something, or is he like, is a quadriplegic, and I'm pretty sure they had it hooked up to a what is it called, to a Tesla Optimus arm, which the Optimus arm is very very nice. Although I don't like the fact that it has kind of grooves for where the joints will bend, but you know, that's irrelevant. As long as it functions, it's fine. I think when I make the final version of this, I'll make it so that it's like more. I'm not exactly sure how to say it. It's more refined. I think I'll try to save up and get a resin printer so that the parts are not only stronger but they're also smoother and just easier to work with, right? And if I can, I'll get like some PCB waste stuff, like get these parts like machine and like 3D prints and stuff. And I fear that it will be very heavy. A metal hand, I mean, just because of how much bulk of the materials that I have here, yeah, I fear that it might be too heavy. So like a good like a polymer hand, I think we would work as well. But yeah, this is a good design for now. I think I'm going to continue working. I'm gonna next time I'll have it printed out, and then I'll do a video of me assembling it and then testing it if it works. So yeah, thank you for watching my Thanksgiving special. I hope everyone had a good Thanksgiving.